In this video, we want to talk about how to find the zeros and multiplicities of a general polynomial. And the specific case that we're going to look at and review in this video is g of x is equal to 4 multiplied by x minus 8, multiplied by x plus 12, multiplied by x minus 5 squared, multiplied by x plus 13 to the third. So it's a pretty ugly or scary looking polynomial, but the good news is it's really not a very hard problem if we're just looking for the zeros. The first step anytime you're looking for the zeros of a quadratic or of a general polynomial is to factor. The nice thing is this is already in factored form, and so that means half of our work or more is already done for us. At this point, honestly, once you know how to do the problem, you can just look at the problem as it is in its factored form and pick out the answers, to be quite frank. Now, what we want to do is we want to find the zeros. We're given the factors. From each factor, we can come up with a zero. So what you want to do is you can underline everything that involves a variable, because those are going to be the individual pieces of this problem we're going to look at. Another thing that I advise doing, and I'm going to do this in red just to show you, is anytime you have a factor, say the x minus 8 and the x plus 12, that don't have an exponent, go ahead and write a 1 as your exponent, because that's going to come in handy in just a minute. So therefore, all of the things that are underlined in blue, your factors, should now have an exponent. So now what we want to do is we want to set each of those factors equal to 0 separately. So we're going to set the x minus 8 equal to 0. We're going to set the x plus 12 equal to 0. And we're going to set the x minus 5 equal to 0. You don't have to worry about the fact that it's raised to the second power. All you have to do is put what's in the parentheses. Same thing with the x plus 13. We're going to set each of those equal to 0, and then you're going to solve all of them. And this is the part that honestly you can really do in your head, once you've had a little bit of practice. All you're doing is you're saying x equals, and you're changing the sign of whatever it was inside the parenthesis. So that's going to give us x equals 8, x equals negative 12, subtracting the 12 across. Our third factor, we would add 5 across, giving us x equals positive 5. And in the final factor, we would subtract 13, giving us x equals negative 13. And so 8, negative 12, 5, and negative 13 are our zeros. So there's half the problem right there. So now comes the part where we want to pick out the multiplicity. Now the multiplicity of each zero, really that's just referring to how many times that zero shows up in the factored form. But the nice thing about this is we already know how many times it shows up because we're given an exponent on all of our factors. And these factors are going to correspond with the zeros. So that means however many times the factors occur, that tells us how many times the zero is going to occur. So all you do is pick off the exponent. So for instance, for the x minus 8, that corresponded to the x equals 8. So we know we have a multiplicity of 1. The multiplicity of our x equals negative 12 is also going to be 1 because that's the exponent attached to that factor. The multiplicity of the x equals 5 is going to be 2 because our exponent is a 2, meaning that factor happens twice. If that factor happens twice, then the 0 must happen twice also. And the multiplicity of the x plus 13 to the third, or of the 0 x equals negative 13, is going to be 3, because again, all we're doing is taking the exponent. And that's it. You now have your factors, your zeros, and their multiplicity. And that's all you need to know.